It began with something that had no business being here. Far beyond the planets, beyond the familiar paths carved through space, by worlds that have circled our sun for billions of years, an ancient traveler entered our cosmic neighborhood. It did not belong to our solar system. It was not returning from some distant orbit around the sun. It had arrived from somewhere else entirely. What made the visitor even more extraordinary was its age. Scientists believe it may be billions of years older than the sun itself. When astronomers realized what they were looking at, they turned one of humanity's greatest scientific instruments toward it, the James Webb Space Telescope. What Webb revealed would reshape the way scientists think about objects born around other stars. This is one of the most remarkable confirmed space stories of recent years. If you enjoy real scientific discoveries explained without exaggeration or internet myths, you're in the right place. Before we continue this incredible journey, please take a moment to subscribe to the channel and help us reach 1,000 subscribers. Your support allows us to keep bringing you carefully researched stories based on verified science and real discoveries from around the universe. Now, let's uncover the remarkable story hidden inside one ancient visitor from another star system. To understand why this discovery matters so much, we first need to understand what normally lives inside our own solar system. Our cosmic neighborhood is a tightly connected family. At its center is the Sun. Around it travel 8 planets, countless moons, asteroids, comets, and billions of smaller icy and rocky bodies. Every one of them is held captive by the Sun's gravity, following predictable paths that repeat over and over again. Everything that belongs to our solar system is tied to the Sun in one way or another. But every so often, something appears that follows no familiar path. Instead of orbiting the Sun, it races toward it from the darkness between the stars. It swings around our star only once before continuing its lonely journey back into interstellar space, never to return. These incredibly rare visitors are known as interstellar objects. For all of recorded human history, astronomers have confirmed only 3. The first arrived in 2017. Its appearance puzzled scientists from the very beginning. It was unusually small, oddly shaped, and tumbled through space in a way no one had seen before. News of the strange visitor spread across the world almost immediately. Yet despite all the attention, it refused to reveal many of its secrets. Unlike an ordinary comet, it showed almost no visible cloud of gas or dust surrounding it. It remained strangely quiet as it sped through the solar system. By the time astronomers understood what they were observing, it had already become too distant and too faint for detailed study. Instead of providing answers, it left behind mysteries that scientists still debate today. 2 years later, another visitor appeared. This one looked much more familiar. As it approached the Sun, it developed a glowing coma and a long tail, behaving much like the comets astronomers had studied for decades within our own solar system. Because it was more active, scientists were able to examine its chemistry in far greater detail than they had with the first visitor. Even so, the opportunity was short-lived. By the time the world's telescopes focused on it, the object was already leaving the solar system, limiting what researchers could learn before it vanished forever. Those 2 encounters taught astronomers an important lesson. If another interstellar visitor ever appeared, they would need more time. They hoped for an object that was brighter, larger, and discovered early enough for the world's newest observatories, including telescopes that did not even exist back in 2017, to prepare detailed observations before it slipped away. For years, they waited. Then, on July 1st, 2025, that opportunity finally arrived. High in the mountains near Rio Hurtado, Chile, a telescope quietly scanned the night sky, just as it did every clear evening. It was part of the asteroid terrestrial impact Last Alert System, better known as ATLAS, a worldwide network built to search the heavens for objects that might one day threaten Earth. Night after night, the system compared fresh images of the sky against those taken only hours earlier, searching for anything that had moved. Most nights revealed nothing unusual, but this night was different. A faint point of light appeared where none had been before. It was moving far faster than ordinary asteroids. Within days, astronomers around the world calculated its trajectory. The numbers told an extraordinary story. This object was not trapped by the sun's gravity. It would never settle into an orbit. It would pass through our solar system only once, before disappearing forever into the vast darkness between the stars. Humanity had just discovered the third confirmed interstellar object in history. It was officially named 3I/Atlas, the 3 marking it as the third confirmed interstellar visitor ever recorded, and Atlas honoring the telescope network that first found it. Almost immediately, scientists noticed something extraordinary about its path. Compared with the 2 visitors that had come before it, this object's trajectory was even more extreme. Every object traveling around the sun leaves behind a signature in the shape of its orbit. Planets and ordinary comets follow graceful loops that keep bringing them back again and again. But this traveler followed no loop at all. It came rushing inward from the depths of the galaxy, curved only briefly around the sun, and then continued outward once more, never intending to return. Its orbit was the most sharply hyperbolic ever measured for an interstellar object. And as it raced through the solar system at well over 200,000 kilometers per hour, astronomers realized they were looking at something unlike anything they had ever studied before. Every clear night, while most of the world slept, a quiet watch continued high above the mountains of Chile. The telescopes of the Asteroid Terrestrial Impact Last Alert System, better known as ATLAS, never stopped searching. Their mission was simple but enormously important: scan the sky night after night, looking for anything that might one day threaten Earth. Most evenings were uneventful. The computers compared millions of stars against images taken the night before, filtering out familiar asteroids and known comets. Almost everything they found belonged to our solar system and followed paths astronomers already understood. Then one night, something different appeared. It was nothing more than a faint point of light racing silently across the darkness. At first glance, it looked like countless other discoveries the system had made before. But as astronomers began calculating its orbit, the numbers refused to make sense. The object was moving far too fast. It was not slowing into orbit around the sun. It was not going to circle back in another few years. Instead, it was following a one-way journey. It would dive into our solar system, swing around the sun once, and then disappear forever into the vast emptiness between the stars. Within days, scientists confirmed what many had hardly dared hope for. Humanity had discovered only the third confirmed interstellar object in recorded history. The object was officially named 3I/Atlas. The number 3 marked it as the third confirmed visitor from another star system ever observed, while Atlas honored the telescope network whose constant vigilance had first revealed its existence. As researchers examined its orbit more closely, they realized this visitor was even more extraordinary than they had first imagined. Every object traveling around the sun leaves behind a signature written in the shape of its path. Planets and ordinary comets trace graceful loops that keep bringing them back again and again. Their orbits reveal that they belong to our solar system, forever held by the sun's gravity. But some paths tell a very different story. When an object races inward from deep space, bends only briefly around the sun, and then shoots back into the darkness without ever returning, Astronomers know they are looking at something that does not belong here. That kind of orbit is called hyperbolic, and 3I/Atlas possessed the most extreme hyperbolic trajectory ever measured for an interstellar object. When it was first discovered, it was already traveling at well over 200,000 kilometers per hour. As gravity pulled it closer to the Sun, its speed increased even further, making it one of the fastest visitors ever recorded passing through our cosmic neighborhood. Yet, its incredible speed was only the beginning of the story. As scientists compared its motion with the average movement of stars throughout our region of the Milky Way, they realized they could estimate how long this lonely traveler had been wandering through interstellar space since being ejected from the star system where it was born. The answer was astonishing. Their calculations suggested the object could be anywhere between 3 billion and 11 billion years old. For comparison, our own Sun and the entire solar system surrounding it is about 4.5 billion years old. That meant something almost impossible to imagine. This ancient comet might actually be older than the Sun itself. It may have formed around a star that lived out its entire existence before our own star had even begun to shine. Long before Earth existed, long before the planets formed, this frozen traveler may already have been drifting alone through the darkness between the stars. For billions of years, it crossed the galaxy in complete silence, untouched by planets, untouched by civilizations, carrying with it the chemistry of another solar system. Then, by pure chance, its endless journey brought it. For the first time in its unimaginably long existence, it passed close enough for humanity to study it. That realization alone is enough to stop and reflect. A frozen fragment of another solar system, possibly older than our own, had wandered close enough for our telescopes to examine it in remarkable detail. And that was when the story became even more extraordinary. Unlike the first interstellar visitor discovered in 2017, which appeared mostly inactive and rock-like, 3I/Atlas behaved exactly like an active comet. As it approached the Sun, sunlight began warming its frozen surface. Ancient ice that had remained locked away for billions of years suddenly transformed directly into gas. Jets of material escaped into space, surrounding the nucleus with a glowing cloud known as a coma, while a faint tail stretched behind it. For astronomers, this was an incredible gift. Inactive, rocky objects keep most of their secrets hidden beneath their surfaces. Active comets do the opposite. As they release gas into space, they expose their internal chemistry, allowing telescopes to identify the molecules escaping from within. Every plume of gas becomes another clue about where that object formed and what conditions existed in its original star system. The comet was, in a sense, revealing its own history. Its discovery was also a reminder of just how much effort had gone into finding it. The Atlas survey never searches for interstellar objects specifically. Its primary mission is far more practical. Every clear night, it repeatedly photographs enormous sections of the sky, comparing fresh images with those taken only hours earlier, searching for anything that has moved. Most moving objects turn out to be ordinary asteroids safely orbiting within our own solar system. Occasionally, the system identifies an asteroid that deserves closer attention because it could one day pass near Earth. That is exactly what Atlas was built to do. Finding a genuine interstellar visitor is something else entirely. It is like discovering a single unfamiliar grain of sand on an endless beach. The odds are extraordinarily small, yet this time, fortune favored science. Not only did Atlas detect 3I/Atlas, it found the object early enough that astronomers around the world had months to prepare before the comet reached its closest point to the Sun. That advance warning changed everything. For the first time, researchers were not forced to chase a fading object already racing away into deep space. Instead, they could carefully organize one of the largest coordinated observing campaigns ever assembled for an interstellar visitor. Space agencies secured precious observing time on some of the world's most powerful telescopes months before the comet's closest approach. Once its hyperbolic orbit confirmed beyond doubt that it had arrived from another star system, observatories across multiple continents joined the effort. Ground-based telescopes prepared alongside giant observatories orbiting high above Earth's atmosphere. One after another, they waited for their opportunity to study an ancient traveler that had spent billions of years wandering the galaxy before briefly crossing humanity's path. Before we continue this journey, take a second to follow the channel if you're enjoying the story so far. Because what happened next was the moment scientists had been hoping for ever since the first interstellar visitor slipped away almost impossible to study. The world's most powerful space telescope was finally about to examine an ancient traveler from another star system, and what it discovered was far stranger than anyone expected. The telescope waiting for this moment was the James Webb Space Telescope, known simply as Webb or JWST. Unlike ordinary telescopes, Webb does not observe the universe the way human eyes do. Instead of focusing on visible light, it is designed to detect infrared light, longer wavelengths that reveal heat and chemical fingerprints hidden from ordinary telescopes. Every molecule leaves behind a unique signature in infrared light, almost like a barcode written across the universe. By reading those signatures, Webb can identify the chemical ingredients inside distant objects that no human eye could ever see. That ability made it the perfect instrument to investigate 3I/Atlas. There was only one problem. Webb had never been designed to chase a tiny object racing across the sky at extraordinary speed. The ancient comet was moving far faster than the kinds of distant galaxies and stars the telescope usually observed. Keeping its instruments locked onto such a rapidly moving target pushed Webb's tracking systems in ways they had never truly been intended to operate. Yet the engineers and astronomers refused to let the opportunity slip away. In August 2025, after weeks of careful planning, they successfully locked the telescope onto 3I/Atlas. For the first time, Webb collected a detailed spectrum from the comet, a chemical fingerprint encoded in infrared light. But the story did not end there. After the comet rounded the Sun and began its long journey back toward interstellar space, Webb turned its attention toward the traveler once again. In mid-December 2025, using another instrument designed specifically for mid-infrared wavelengths, the telescope recorded the most detailed chemical analysis ever obtained from an interstellar object. Then the data arrived. As scientists began studying the results, they quickly realized this comet was unlike the familiar icy visitors they had examined for decades within our own solar system. One of the first surprises was the balance between two common cometary ingredients. The comet was releasing an unusually large amount of carbon dioxide compared with water vapor. For astronomers, that ratio immediately stood out. Comets born within our own solar system generally follow predictable chemical patterns as sunlight warms their icy surfaces. Over decades of observations, researchers had developed a good understanding of how much water and carbon dioxide these objects normally release. 3I/Atlas did not follow those expectations. Its chemistry hinted that it had formed in an environment fundamentally different from the one that created the comets orbiting our own sun. And then came an even greater surprise. Hidden deep within Webb's mid-infrared observations was the unmistakable signature of methane gas escaping from the comet. It was a historic discovery. For the first time in history, scientists had directly detected methane coming from an interstellar object. The discoveries continued. Alongside methane, Webb clearly detected water vapor and carbon dioxide. But there was something else buried within the data that almost no one expected. A distinct atomic signature revealed the presence of nickel. Finding nickel escaping alongside the comet's gases was unusual. It provided another valuable clue about the raw materials that had become part of this object billions of years ago while it was forming around a completely different star. To understand why methane attracted so much attention, it helps to understand the molecule itself. Methane is incredibly simple and remarkably fragile. Over immense periods of time, cosmic radiation slowly destroys exposed methane molecules. An object wandering alone through interstellar space for billions of years would spend every moment bombarded by that radiation, with nothing to shield its surface. Because of that, scientists never expected large amounts of methane to survive on the outside of such an ancient comet. Yet Webb detected a strong and unmistakable signal. The discovery forced researchers to rethink what they were actually seeing. Their explanation reached beneath the comet's frozen crust. They believe that over billions of years, cosmic radiation gradually stripped away much of the methane from the comet's exposed outer layers. But deep beneath that weathered surface, untouched material had remained safely protected. As 3I/Atlas approached the sun, sunlight heated the comet until those ancient outer layers began to evaporate away. Only then did the hidden interior become exposed. The methane Webb detected was likely escaping from this deeper, pristine material. Material that had remained sealed away for billions of years, protected from cosmic radiation until its brief encounter with our sun. That realization transformed the entire discovery. Webb was doing far more than studying the comet's surface. It was peering directly into ancient material that had remained locked away since long before our own solar system existed. Think about what that really means. A group of scientists aimed a telescope at what looked like nothing more than a tiny moving point of light. From millions of kilometers away, that telescope decoded the chemical ingredients of a frozen fragment from another solar system. Those molecules had remained hidden for billions of years, untouched, unchanged, waiting silently through the lifetime of stars until, by an extraordinary coincidence, they were finally revealed during humanity's brief moment of technological history. It is one of those rare moments in science that makes you pause, not because of speculation or imagination, but because reality itself turns out to be more remarkable than anyone expected. But the James Webb Space Telescope was only one voice in a much larger scientific effort. As Webb continued reading the comet's chemical fingerprints, another legendary observatory was quietly watching the same traveler from orbit. The Hubble Space Telescope had joined the investigation almost as soon as 3I/Atlas was discovered. Unlike Webb, whose greatest strength lies in analyzing chemistry through infrared light, Hubble excelled at something different. It helped scientists answer a much more basic question. How big was this ancient visitor? That question turned out to be surprisingly difficult.